Hello, welcome. As a part of Programming for Problem Solving Lab, I am Sandhya and today we will look at some operations on arrays. And we are going to look at a searching technique. We are going to take into account a lab program, a lab task 6C. So what is 6C? Lab task 6C is a concept of implementing binary search. So what is binary search? We have already seen that binary search, this is lab task 6C, write a C program to implement binary search. We will, in this concept, prefer using a function and then implement binary search. Okay, so let us first of all take an example of binary search and visualize an example first so that we can proceed and go ahead to design a program. Okay, so this is a simple binary search algorithm, and here is a sorted list. So this is cs.usfca.edu, where we have some implementations of visualizations of algorithms. So I'm searching for an element. Let me search for an element in a sorted list. Let us assume that I'm searching for some element called 166, and I want to implement binary search. So therefore, let me just start. So how is it working? The first list is 0 and 31. So you find out the mid element, that is 15. So therefore, again, you're trying to find out the mid element 7. This is how, 0 and 7. Now the mid element is 3 and you're at 3. Now the range is 3 and 4. 3 is 4, mid is 5 and high is 6. Okay. So finally, everything clubs and searching for 166. Yes, the result is found at 6. Okay, so you can visualize more algorithms. I'll share this link at the end of the video. You can visualize more algorithms by using the, by adjusting the animation speed. You can also search for something, let me now take a minute and search for element one, which is not there in the list, an element one, and let me adjust the speed. I'm using binary search. So therefore, let's just proceed and have, like little slower. So yes, you're searching for one, check out. Now 0 and 14, mid element is 7. So again, so it will be in the front list. So therefore 0 and 6, the middle element is 3. Now again, 0 and 3, it will be first. So therefore the middle element is 0 and 3, it's 0 and 2, the middle element is 1. Again, so you're searching for 0, the lowest 0, highest 0, mid is also 0, but the 0 element is not same. So therefore your high becomes -1. Please understand, your high becomes -1. 0 and -1, so it violates the condition that that it is less than the data. Lower boundary less than or equal to upper boundary. 0 less than or equal to -1 is false. So therefore you'll stop returning -1, returning -1, indicating that the search is unsuccessful. So this is a good kind of visualization where you can check out how does your program work. So therefore let's now directly see the code. We are going to execute binary search in this concept. So Alt F. Let me open a program. What is binary search? Binary search is based on divide and conquer technique, where you try to see the where you are expected to have a sorted list. So therefore, this is a simple C program where I expected to have a sorted list. So dear students, I have here a sort function. I employed a sort function. This is a sort function which I employed, and then I'm checking. Okay, so let me save the code, or else, let us call, yes, let's compile. Let me compile first. Let us run and then check how is it working. Let us run the program. This is a simple binary sorting technique. Number of elements 5. Let me put some unsorted list. 53902. 53902. Binary search basically requires sorted list. So therefore I have a sort function included. So it sorts the list. This is needed because we have to pick out, what is the position. Now I want to search an element. Let me search for 1. Yes, it says 1 is not found in the list. Why is 1 not found in the list? Because my list is 0 and 1 is not there. 0 and 2, 1 is missing. So therefore, yes. Let's again run this code to search for some sorted elements. Enter number of elements is 6. So 3, 1, 8, okay, sorry. 39 and some 0. Yes. Now the list is 0, 1, 3, 8, 9, 30. Let me search for an element that is 1. Now, yes, one is found in the list at A of 1 and the search is successful. So let's just take into account bubble sort and binary search. So here I have read the elements of an array and then I have a bubble sort technique. What is bubble sort? We'll see. There's a video already. Please look at that. Bubble sort is a sorting mechanism which tries to, put the data in an order. So this is the sorted list. After printing the sorted list, here is the code for, binary search. Set your first, that is lower boundary to 0, last, that is upper boundary to n minus 1. Find is something that where you're storing your position. Initially it is set to -1, indicating that the element is not found. While off, your lower boundary less than or equal to upper boundary, find out the middle element, that is first plus last by 2. If key is same, then set your find to middle and break. Because I got my element, I'll just break. Otherwise, if it is greater, indicates that it is in the first list, so set your lower boundary to mid -1. Else implies that it is in the second list, so therefore set your upper boundary. Sorry, set your lower boundary, that is, first to mid +1. If your find is not equal to -1, then you say that the list is successful or the search is successful. So therefore I say here, search is SUCCESS. Search is successful /n. Otherwise you say that your search is unsuccessful. Otherwise you say that your search is unsuccessful. Okay, so this is how you save your code. Compile and run. Let's run for just 3 elements, 7, 1, and 4. Okay, so the sorted list is 147 and I'm searching for, say suppose I'm searching for, yes, I'm searching for 7. Yes, search is successful. 7 is found at A of 2. So yes, this is what we do. So there is recursive and iterative way of doing it also using functions. So let's see if there is any function. Yes, any program using functions. Yes, this is the lab task that we are talking about, and I used functions here. This is lab task 6C. Dear students, this is lab task 6C. 6C. So in this lab task 6C, you're going to see, I've used a function bubble sort to sort my elements, and binary search is the function. So this is just my function. This is a function that works on an array A of n elements, taking the key, it searches for the key, it sets the lower boundary to 0, upper boundary to n minus 1. Again, while of lower less than or equal to higher, it continuously finds it and then just returns -1 in case of some unsuccessful operations. Otherwise returns, mid when you know that it is successful. Okay. And you know that it is success, it returns mid. Okay, so let's just run the code and see. Errors, okay, missing some semicolon. Okay, yeah. Alt F save, compile and run your code. Okay, an array of size 5, 1, 6, 3, 2, 0. Enter the element to search. I'm searching for 6. Yes, this is the sorted list and the element is found at 4. 0, 1, 2, 3, 4. Okay. So likewise, you can also find out the unsorted elements as well. So I recommend all of you to, write down the code on your own to ensure that you get the right output and practice binary search, which is the most important searching technique. Good day.